Okay, and so anytime you have an equation, a quadratic equation with an x squared, you can start putting it in vertex form because we can complete the square now. Okay, so once again, we're just going to solve for ax squared plus bx, complete the square, and put the equation in vertex form. All right, the only difference is we're not set equal to 0 this time. We're actually set equal to y. All right, and so nothing's going to change. I still want the x terms on one side, the y terms, the numbers, everything else on the other side. Okay, but we're just going to write it in vertex form. So here we go. Let's take a look here. As you can see, the difference now is that we have two variables, and we're not just solving an equation. All right. What we need to do is this. Okay, we're not finding the zeros, we're not doing anything else. We're just completing the square to put it in vertex form. All right. And remember, in vertex form, okay, we know that this is the vertex, HK, where H is the opposite of what you think it is, and A makes the parabola go steeper or wider. Okay, the bigger A gets, the steeper it gets, the smaller, the wider it gets. If A is negative, it goes down. Okay, this is stuff we've already graphed before. Okay, but the benefit of completing the square is now we can put things in vertex form. I'm going to show you how here. I'm going to complete the square by solving just for the ax squared plus bx again. So I'm going to subtract 17 from both sides. It used to be 0 over there, now it's just y. Nothing changes. You can't add a negative 17 with the y, so we just leave it. Y minus 17 equals x squared minus 8x. My a value is 1, which is good. So now I complete the square. Negative 8 divided by 2, quantity squared, which is negative 4 quantity squared, 16. So what I'm actually going to add to both sides is 16. However, I know that in my factored term, I'm going to have minus 4. So I'm going to say x minus 4, quantity squared. And that's equal to y minus 1. However, in vertex form, I need it to be y equals, so I'm just going to go ahead and move my number back over there, and that's going to be my k value. Y equals x minus 4, quantity squared, plus 1. And so let's just talk about what it means in vertex form. I know my vertex will be at 4, 1, and I know my a value is 1, so it'll be a nice open parabola, okay, at 4, 1. And then we could solve some values and make it a little more accurate from there, but we can get a lot of information from this just by completing the square. All right, so let's look at another one here. I just want you to put this in vertex form. Okay, put it in vertex form. So once again, we're using completing the square to do this. We're going to subtract 3 from both sides. Y minus 3 equals x squared plus 6x. And I got to check my a value, make sure it's 1. It is, which is good. So I'm going to complete the square on the right-hand side. 6 divided by 2, quantity squared, is 3 squared, which is 9. This 3 is going to help me later, but I'm adding 9 to both sides. Y plus 6 equals x plus 3 quantity squared. Okay, and as you can see, this 3 came back and it went right in the parentheses. All right, from there, we're not solving anything. We're just writing in vertex form. We can subtract 6 from both sides. Y equals x plus 3 quantity squared minus 6. So let's just talk about what this parabola would look like, this quadratic would look like. It'd be a vertex at negative 3, negative 6. Okay, this a value is positive. It tells me it opens up. Okay, so we can get a lot of information from having an equation in vertex form. Finally, we have an f of x example. Okay, an appearance of the f of x. All right, nothing changes. We're doing everything the same way. Okay, we want it in vertex form, which is y equals a, x minus h, quantity squared plus k. All right, so we're going to have to add the 4 and get rid of that number over there. We just want ax squared plus bx. So we have f of x plus 4 equals x squared minus 4x. And we're going to complete the square. Negative 4 divided by 2, quantity squared, and negative 2, quantity squared, which is 4. I'm actually adding 4 to both sides, but this number in here is going to help me factor on the right-hand side. So I have f of x plus 8 equals x minus 2 quantity squared. Now I can subtract 8 from both sides. F of x equals x minus 2 quantity squared minus 8. So the benefits, once again, we have a vertex at 2, negative 8. Positive a value is going to open up. We'll have a min at 2, negative 8. So there's a lot of stuff we can take from that. Now, I know this last example isn't on your notes, but I want to just talk about it real quick. Oops. Now, I know this last example isn't on your notes, but I just want to talk about it real quick. Okay, you may get something where there is a number in front of the x squared. Okay, you may get y equals, say 3x squared minus, let's just say 9x plus 3. Okay, and to write this in vertex form, you continue, you do the same steps, minus 3 on both sides, y minus 3 equals 3x squared minus 9x. Okay, and what you can do is this. Okay, and I didn't show you this earlier, but if this makes more sense to you, you can do this way. Y minus 3 equals, okay, I need to divide both sides by 3. We'll just say x squared minus 3x. Now what I'm doing is I'm adding to both sides, okay? And so this is where things can get tricky. Okay, I'm completing the square. Negative 3 divided by 2, quantity squared. Nothing reduces, so this is what's actually going to be in my term here. That's 9/4. I'm adding 9/4 to both sides. All right, but the 9/4 doesn't go in the fraction. It's actually a separate fraction. So what we're going to do is this. We're going to say y minus 3 over 3 plus 9/4 equals x minus 3/2 quantity squared. Okay, and so that's part of my vertex there. Okay, I need to solve for y. So I need to undo all this multiplication, all this division. So what I'm going to do is to both sides, I'm going to multiply it by 12. And the reason I chose 12 is because it'll cancel out both fractions at the same time. That cancels out and gives me 4 times y minus 3. 4 times y minus 3. And this cancels out over here and gives me 3 times 9. All right, so when I simplify this, what I'm actually going to have is 4y minus 12 when I distribute. And on the right side, I'm going to have minus 27. Okay, when I continue on, sorry, I'm going to have plus 27 when I continue on, plus 27 equals 12 times x minus 3/2 quantity squared. Okay, and so now I continue to solve here. I'm going to say 4y plus 15 equals 12, x minus 3/2 quantity squared. I'm going to subtract 15 from both sides. 4y equals 12 times x minus 3/2 quantity squared minus 15. And finally, I'm trying to find y, so I'm going to divide both sides by 4. So my final solution actually is going to be, okay, if I cancel out, if I take 4 into this term, I get 3 times x minus 3/2 quantity squared. And I have to also divide into this term as well, minus 15/4. So y would equal 3 times x minus 3/2 quantity squared minus 15/4. Okay, and so now the vertex is 3/2 negative 15/4. The a value is 3, so it's going to be a little steeper, and it'll be a min value. All right, now I just kind of made that problem up. It wasn't a very good example, obviously, but you get the idea, okay? When you're done completing the square, you still need to solve for y and get your solution.